In higher level math classes, we often need to perform algebraic operations with functions instead of just evaluating them at a single number or solving for a particular numerical value. Let's go ahead and practice this here since we are working with functions in this section. So let's say we have f of x equals 3x minus 2, and we have a second function g of x equals x squared minus 6x plus 3. As a first step, let's look at evaluating f of a plus 3. Notice a plus 3 is entirely in the parentheses of this function, so it is the entire input. Normally, we're used to having an input like 8, so f of 8. So we're used to having a numerical input. So if we had the function f of x equal to 3x minus 2, and we were told to find f of 8, we would put the 8 in wherever we see x and then calculate. If we had f of negative 5, we would put the negative 5 in wherever we see x and calculate. If we have, say, here's something silly, f of smiley face, then we would put smiley face in wherever we see x and calculate if possible. So here what we have is a plus 3. So the idea is we're going to do the same thing we would do with any number or silly happy face. We're going to put a plus 3 in wherever we see x. So in this function we start with the 3 and then we want to put this a plus 3 in where we see the x. Now because a plus 3 is two terms, we want to surround it with parentheses, just like I did over here for the 8, the negative 5, and the smiley face. But it's essential here. And then we're going to subtract the 2 because that's still part of the function there, is to subtract 2 after we multiply by 3. Now you can see why I said to simplify instead of just calculate with these examples. We can't calculate without knowing what a is. Instead, we're just going to simplify as much as we can. The 3 is outside the parentheses, so we're going to distribute the 3. So we're going to get 3a plus 9 minus 2, and then collect like terms. So we'll have 3a plus 7. So in the end, we took f of a plus 3 and found that it was equal to 3a plus 7. What we did here is we performed algebra within the function notation. Let's look at another example. Let's say we have g of 5w. To find g of 5w, we're going to take all of 5w and put it in wherever we see the x in this function g. So the function function g has an x that gets squared and an x multiplied by negative 6, and then don't forget we add 3 at the very end. So if I plug 5w in, I'm going to have to plug it in and square it. Then I'm going to have to subtract 6 and multiply by that 5w, and then don't forget to add 3 at the end. So I have to perform all these operations. So the 5w is squared. 5 times 5 is 25, w squared. 6 times 5 is 30, so I'm going to have negative 30w, and then plus 3. Now in this case, there's nothing else I can collect. So remember how I said sometimes it ends up being a little simpler? In this case, all I got when I took g of 5w is I got this statement, 25w squared minus 30w plus 3. Even though the setup is a little harder, there's not as much to calculate because I can't without knowing what w is. So again, we're using algebra or within the function as an input. Let's do a few more examples. We'll use the same equations we had earlier. F of x equals 3x minus 2, g of x equals x squared minus 6x plus 3. In our first example, we have g of x plus 3 minus 7. Now notice that only the x plus 3 is in the parentheses for the function g, so that means we're only going to put that x plus 3 into the input of g. Remember, g takes an x value and squares it, and then subtracts 6 times that x value and then adds 3. So I'm going to replace x with the quantity x plus 3. So when I do that, I'm going to have x plus 3 in the place of x, and remember at the beginning x gets squared. Then I'm going to take minus 6 times all of that replacement of x plus 3. Then I need to make sure I have that 3 there, and then finally now that I've done all of g of x plus 3, I'm going to subtract 7 because I still had that minus 7 at the end to take care of. Now I need to simplify. So I've got x plus 3 quantity squared. That really means x plus 3 times itself. I've got minus 6 distributed into the x plus 3, so minus 6x minus 18. I've got plus 3 and negative 7. If you want, you could go ahead and add those together right there, minus 4. FOIL these two out. X plus 3 times x plus 3 is x squared plus 3x plus 9 minus 6x, and negative 18 minus 4 is negative 22. Continue to collect like terms. X squared. 3x plus 3x is 6x, but I'm going to subtract the 6x so the x's actually go away. And then I have plus 9 minus 22 is negative 13. So it turns out in the end, even though it looked really complicated at the beginning, g of x plus 3 minus 7 is equal to x squared minus 13. So evaluating a function expression with algebra. Next example, 5 times f of 3r plus 2. The 3r plus 2 is inside the parentheses for the function f. So wherever we see x, which was our original input in this function, I'm going to put 3r plus 2. Now the 5 is outside of that, so that means the 5 is going to multiply whatever I get when I plug 3r plus 2 into the function. So I'm going to use brackets to emphasize that I'm going to multiply that 5 after the fact. So plugging 3r plus 2 in, I'm going to have 3 from the original function times 3r plus 2, and then don't forget in the function I have a minus 2 at the end. When we simplify, we always follow order of operations. So the 5 is going to multiply last. I'm going to multiply the 3 in first. 3 times 3r is 9r plus 6. Then we're going to subtract the 2, keep working on the inside. 5 times 9r plus 4. And finally, there's nothing else we can do on the inside, so we're going to just finally distribute that 5. So we get 45r plus 20. So 5 times f of 3r plus 2 ends up being 45r plus 20 in the end. In the last example, we're actually going to solve this equation. Now in this equation, I have two functional values. I have f of a plus 5. So what this is saying is take a plus 5 and put it into the function f. So 3 times a plus 5 minus 2 would be the function f evaluated at a plus 5. And then for the function g on the right side, it says plug a in. So if I plug a into the function g, I would get a squared minus 6a plus 3. So I end up with an equation, and that's why I said solve the equation. We're going to solve for a here. So I need to simplify some stuff first. I'm going to distribute the 3. So 3 times a is 3a. 3 times 5 is 15. Minus 2. A squared minus 6a plus 3. 3a plus 13 when I collect like terms equals a squared minus 6a plus 3. Let me pause here for a moment. This is probably going to be a quadratic because of the a squared, so let's get everything on one side. I'm going to make that a squared is positive now, so I'm going to put this, make the 0 be on the left-hand side. So I'm going to subtract 3a from both sides. So negative 6a minus 3a is negative 9a. And then subtract the 13 as well. 3 minus 13 is negative 10. So I'm going to get 0 equals, and I need to factor this side, a minus 10 times a plus 1, I think will work. You can double check that factorization. And then we can set each of these factors equal to 0 to solve. So a is 10, and then a plus 1 equals 0 results in a equal to negative 1. So we actually get two solutions. we get the solutions are -1 and 10 here. But the major part of this problem that I want you to kind of see is what we mean when we say evaluate a function or find f of a plus 5. It's just taking that a plus 5 and putting it in as the input, or g of a, put a in for the input. This is not so much different than a number, but it is a little bit more abstract, and we need to just get used to that for higher level classes.